Okay, hello everyone. Today we'll solve another problem of orthographic projection. The question where they ask you have to draw any two views or all three views. They may ask you to draw a front view, side view, or a front view, top view, or they ask you the draw front view, top view, and side view. So for the study purpose, we'll or practice purpose, we'll draw every time all three views. So now this is a object and this is a given direction, x direction. So in this direction you have to draw front view, right? So which side view is visible? See, if this is a front view, then this is a left hand side view, and this is the from this side we have to draw top view. So let's decide its position. So first you have to draw this x1 y1 line, xy line perpendicular to each other. Then you have to draw these parallel lines, right, on the both side of xy line at a distance of 1.5 centimeter or 1 centimeter. So draw this parallel line. Okay. Then we'll decide the position. So front view, you have to draw left hand side view and the top view. So here we'll draw the front view, and at the right side of a front view we'll draw left hand side view. At the right side of a front view we'll draw left hand side view, and here we'll draw the top view. Front view, here left hand side view, and here top view, because we are drawing this object by first angle projection method. Okay, in a first angle projection method, left hand side view appears at the right side of a object. Now we'll calculate the overall dimension of object. Now see, in a front view which two dimensions are visible? This 120, which is the length 120, and its total height. So the total height is 50. Yes, 50 plus 20, right? So 120 and it is 70. So we'll mark it here. So you have to mark that distance from this line, not from the x1 y1 line, right, or xy line. You have to mark it from this point. So 120 this side. So this is, let's say, 120 mm distance. Okay, 120 mm distance, and this is 70 mm distance. So we'll draw the overall, or mark the overall dimension of front view. So this is 120 and this is 70. Now in a top view, which two dimensions are visible? This 120 and this distance. Okay, now this dimension is not given, but see, this distance equal to this distance, right? So let's see, the radius of this outer circle, half circle, is given, which is r30. So this total distance is 60. So obviously this is also 60 mm distance. So you'll get this 60 mm, the overall width 60, and overall length 120, which is visible in a top view. So we'll mark that distances here. So that 120 mm distance we have in a front view. So we'll project that 120 mm directly in a top view like this. Okay, so you'll get 120 here, and you have to mark this 60 mm. So we'll mark that 60 mm this side. Right. So this is 120 and this is 60. Okay, overall dimension of top view. Now we'll mark the overall dimension of left hand side view. So in a left hand side, this 60 mm distance, and overall height is visible, that is 70. So height we have that 70 mm in a front view also. So we'll project it here. So you'll get 70 mm here, and the 60 mm, 60 mm width is here, which is available in a top view. So we'll project it side view. So for that you have to draw here a 45-degree inclined line, and to project this 60 mm dimension in a left hand side view, you have to project it up to this 45-degree line like this, right? And then here you have to draw vertical lines. Here I will use okay. So here I'll get this 60 mm distance here like this. So now we mark overall dimension of front view, top view, and side view. Okay, now we'll start the front view. So first, to draw the front view, which surfaces are visible? See, this surface is visible, then this surface is visible, this surface is visible. So first we'll draw this surface. Okay, so let's mark this 20 mm distance from the, yes, the rightmost corners from here of the front view. So 20 mm, mark that 20 mm distance, right? This 20 mm, then this edge, this dimension is 45, so mark that 45 mm distance, 40 mm. Then this vertical line, right, just throughout the throughout the 70 mm distance, right? So 70 mm, 70 mm. Then again this is 20, so let's mark the 20 mm distance again. Then we'll draw from here horizontal line and from here vertical line, right? So you will get this intersection point. So we'll draw this first surface which is visible in a front view, correct? Now see, from this side, here there is a hole in this surface, right? Okay, so this hole is not visible from the front side. This hole is not visible from the front side, so you have to draw the dotted line. For invisible edges we use dotted line, and for the visible edges, means these are the visible surface, these are the visible edges, so we use here the dark line for it. But invisible part means this hole is not visible from this side, so for that we will draw our dotted lines. Okay, so now this is a cylindrical hole. So for the cylinder, let's say this is the cylinder, from the front side it looks like a rectangle, right? It looks like a rectangle. So from this side it looks like a rectangle, but it is an invisible rectangle, right? So let's first mark its center. So from this edge, it is at a 25 mm distance. Its center is at a 25 mm distance. So from here we'll mark 25 mm and we'll draw the center line. Then its diameter is 520. So from the center line, this side 10 mm, this side 10 mm, and we'll draw that rectangle, right? Here already there is a dark line, so even if you draw the dotted line, it is not visible, right? So this is the rectangular portion of this circular hole from front side. It is not visible from front side, so we will show it as a dashed line. Clear, everyone? Okay, now we'll draw this portion. Okay, now this is the circular curved surface, but from the front side it looks like a plain surface, right? See, this curved surface looks like rectangle here in this plane here. Okay, so we'll draw that portion. So its height is equal to the radius of that half circle, so it is 30. So we'll from here we'll mark that 30 mm distance, 30 mm. Okay, and this is 50, means 50 up to here. Right, so it is looks like a rectangle again from front side, because that curved surface is not visible. It appears like a vertical surface from the front side. Okay, so this is that portion. Okay, so this curved surface appears rectangular from the front side. Now there is the half circular hole also. Now this half circular hole is also not visible from the front side, right? So that you have to show that half circular portion the front side as a dotted line. So again this half circular portion looks like a rectangular from the front side, right? Okay, so the radius of this inner half circular hole is 20, R20. So from here R20 will mark 20 mm distance, right? And it is, let's consider up to the 50 mm distance. So we'll draw this dotted line up to here, right? And if you draw dotted line here, because already there is already a dark line of this bigger half circle, so it is same and all, so no need to draw that dotted line over here. So just this dotted line is there. Okay, this is for this inner half circular hole. Because it is not visible from the front side, we show that as a dotted line. Okay, now last portion, this last surface is visible in a front view. So this is a wedge. So this starts from this surface, means from this surface, and it ends at this half circular portion, means here. So we'll just join this. So you will get this surface. Yeah, so this is our front view. Now we will give dimension. So this is 20, right? This is 45. This is 25. Then this height is given, which is 50. This overall length, (120). Okay, so now we'll start the top view. Now from the top side, which surface is visible? Yes, this surface is visible. Then this wedge is visible. This curved surface is visible. Okay, so to draw this surface, where is that portion in a front view? Means this portion, right? So we can project that, right? So 45 and this is 60. So 45 dimension we have in a front view, so we'll project it downward. So, and this is 60, this is 45, this is 60, 45, 60. So let's draw that surface. Then we'll draw this hole. We have that projection also. So we'll first project center line of hole, right? It is at the center of this 60 mm distance, so we'll draw the center line. So we'll get center of hole, and with a rounder draw this circle of diameter 20 mm. Okay, then we'll draw this curved surface. Okay, before drawing this curved surface, see, from the top side you draw this surface, right? But from the top side, this edge, right, this is a corner, means throughout corner, right? So this edge is not visible from the top side, right? So you have to show that as a dotted line, means from the top side this this corner is nothing but this. So you have to draw this as a, that edge is as a dotted line. So project that corner, and you have to show this edge as a dotted line throughout the 60 mm distance, because it is throughout the 60 mm distance, this corner, right? That edge is not visible from the top side, so we show it as a dotted line. Clear? Now we'll draw this surface, curved surface. Now as I told you, from this side also that curved surface looks like a rectangle or a plane surface, and from the top side also it is looks like a plain surface. Only in a front side you can see that curved surface, right? So we'll project this portion. So this portion is here in a front view, right? This portion, so we project it downward, right? And this is 60, so 60 by this is 50, and this is 60. Correct. So this is that curved surface in a top view. Then we'll draw this wedge. Wedge starts from this surface and ends at this surface. So see, here we can project, this is the wedge portion na? So it starts from this edge and it is at the center of 60 mm distance. It is at the center of the 60 mm distance. So 60 mm के center पे आपको ये draw करना है wedge. So this wedge dimension is 12. So from the center 6 mm this side, 6 mm this side. Here also mark 6 mm, 6 mm. Right. A wedge starts at this point and ends at this point. Right. From here to here. We'll draw that wedge. Again, see, from the top side that inclination is not visible. That inclination is visible in a front view, right? Inclination is visible in a front view. But from the top side it appears in this portion. Right, in this plane. It looks like a plane or a horizontal, right? But actually it is inclined, but that inclination is not visible from the top side. It looks like it looks in a same plane of this surface. Clear? Now the last thing in the top view is see, this half circular hole is not visible from the top side again, right? It is visible from the front, this side view, right? So from the top side it looks like a dotted line again. So for that, see, again this dimension, its radius is, this inner half circle radius is 20. So from the center line mark here, radius is 20. So from here 20, and from here, from the center this side 20, and this half circular hole is up to, let's say, this surface. Then we'll draw the dotted line for it, right? For this edge, right? For this edge and for this edge we'll draw this two dotted line. Clear? Now we'll draw the side view. Now in a side view, first we'll draw this half circular portion. Now see, this curved surface is visible in a side view now. So this outer radius is 30 mm and inner radius is 20 mm. So here we'll mark the center line. We'll mark center line. Okay. So from here, this is already 60 mm, so we can draw that half circular portion. Right, then inner radius is 20, so 20 mm, and we'll mark this is as a dark edge, and this edge is not there, right? यहाँ पे कोई edge ही नहीं है क्योंकि वो hollow portion है, so there is only edge. Then we'll draw this surface. From the left side this surface is visible, so dimension is, this is 60 and this is 70, so 60 and 70. Clear? Then we'll draw this wedge, right? Which starts at this surface, right, and ends at this surface or this point, right? So 12 mm this side, 12 mm this side. Again the inclination is not visible. Inclination is not visible in a side view also, right? So we'll draw that wedge here. Okay. Then from the front side which part is not visible from the left hand side view. See, this circular hole is not visible from the left hand side view, so for that you have to draw the dotted line, right? So let's project that hole from the front side. So you have this height of hole, so project it, and from the left hand side view also you have to show the dotted line, cylindrical dotted line for this circular hole. So its radius is 20. So from the center 10 mm this side and 10 mm this side, you have to draw this dotted line. Okay. Then from the left hand side view, this edge is not visible, right? This edge is also not visible, but from left hand side view, this edge overlaps with this edge, this edge is overlapped with this edge, so both edges are not visible from this side, from left hand side view. So for that you have to draw dotted line, means this edge is not visible from the left hand side view, so for that you have to draw dotted line here. Right, so this is complete left hand side view. Now remaining dimension will show in a top view. So 120 we give here, so here you can mention the inner radius is r20, r30, then this wedge dimension you can show here, it's 12 mm, right? The diameter of this circular hole is 20, right? Okay, so we cover almost all the dimension. Okay, so this is front view, top view and side view of an object. Remember the hidden part we always show by the dotted line. Always we shows hidden part or hidden edges with a dash lines, and the visible portion with a dark lines or a object line. Clear everyone? Okay, thank you.